All right, problem set 14, numbers 35 and 36. It says find the standard form of the equation of the ellipse, find the center vertices and foci and eccentricity, use a graphing utility to verify the results, and then in 37 and 38, find the standard form of the equation of the ellipse with the given characteristics. And that the examples there were center at the origin. Okay, so we'll see, we'll come back to that. So big ideas. First of all, our formula is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Or x minus h squared over b squared plus y minus k squared over a squared is equal to 1. This has a vertical major axis. This has a horizontal major axis. So what do we do in the first case? Well, first of all, we need to have perfect squares on x and y. I need to have a 1 on the right-hand side. We need to have fractions. So what we're going to do is we're going to go ahead and gather our x terms. So minus 64x plus 25y squared minus 150y equals 111. I'm then going to take the 16 out of here because we can't complete the square with a coefficient other than 1, plus factor 25 out of here. So first, we take half of negative 4, which is negative 2, square it. That gives me plus 4, which means we are changing this entire left side by 64, so we add 64 on the other side as well. Here, half of negative 6 is negative 3. Negative 3 squared is 9. 25 times 9 is 225. So now I have 16 times x minus 2 squared plus 25 times y minus 3 squared equals, and then 225 plus 64 plus 111 gives me 10, gives me 400. All right, we're getting there. I need a 1 on the right-hand side, so we divide all of these terms by 400. So I get x minus 2 squared over 25 plus y minus 3 squared over 16 is equal to 1. So I now know we have a horizontal major axis. So I know a squared is 25, so a is 5. B squared is 16, so b is 4. Remember, c squared is equal to a squared minus b squared. So that's 9. So c is 3. So let's figure out what we have here. Here I have the center at positive 2, positive 3. My vertices, because it's horizontal, they're going to be 5 to the right and 5 to the left of this point. Now, if it helps, go ahead and kind of draw a little bit of a sketch here. Over 2, up 3. I find that when people sketch it, they're able to see a little bit better where these vertices go. But again, we're moving 5 to the right. So 5 to the right of this point would be the point that is out 7 and up 3. And 5 to the left would be negative 3, 3. Now, it doesn't ask for covertices. Some books, I think, just call all 4 of them vertices. I'm just going to write covertices. These are going to be the points that are up and down on the smaller or the minor axis. Those are going to be 4 above and below this point. So go up from 2, 3, go up 4 and down 4. And I get the points 2, 7 and 2, negative 1. My foci are c units away from the center on the major axis. So again, from the center 2, 3, go to the right 3, to the left 3. So if I go to the right 3, I get 5, 3. Go to the left 3, I get negative 1, 3. And then we need the eccentricity, which is just c over a, so we get 3 over 5, which is 0.6. Okay. And then for questions 37 and 38, you just kind of work backwards from that. In other words, you're usually given the center and vertex or center and a foci. So you're going to use that to find A and C and B, and then work your way back from there to get the equation. Okay. Hope that helps.